Greetings, everyone. Welcome back. In this particular video, we're going to talk about the 5 types of agentic AI. I have one, two, three, four, five, putting it all together and the agentic flow at a glance. The components would be our next video. Very good. Let's begin right from here. We have instant rule follower. As you can tell from that, that's an if-then-else scenario. Context keeper, so some memory is in place in here. Goal-driven tool user, decision optimizer, and self-improving autopilot. Let's begin. The instant rule follower reacts now. It has no memory. Here's an example. The thermostat. If temperature is below a certain set point, heat on. Keyword autoresponder. If message contains refund, send a policy link. Who's a favorite of yours? Access badge. If badge is valid, unlock. And how many times has that happened to you that the badge was valid and it did not unlock? I remember quite well. Emphasize reactivity and zero memory. Great for predictable triggers. Brittle when context matters. Moving on. Context keeper. You can already tell an example from that image. Keep an instant state, a model of the world to handle partially observable situations. It still uses rules, but it is informed by memory. For example, the robot vacuum, it tracks rooms that are already cleaned, so it doesn't clean what it has gone over. Or so we hope. The support bot remembers ticket ID, and the last error across turns as it goes reiterates. The elevator controller tracks direction and the queued floors. So that is an example of a context keeper agent. In contrast to the instant rule follower, this agent can switch context across steps, but still remains primarily a rules-based artifact. How about the goal-driven tool user? That image should tell you a tale of examples to come. It plans upcoming steps and it calls tools. GPS, for example. Here's one example. A travel planner finds flights, book hotel, build an itinerary to meet the budget. So you can imagine how many APIs are at play in here. And for each of the tools, perhaps an MCP that is calling or accessing those tools. A classic example is GPS navigation planning a route to a destination. Meeting scheduler checks calendars, proposes times, sends invites. So the agent chooses tools to reach a target, not just react. It performs a plan, it acts on it, it checks the loop. Onward, decision optimizer. Balances trade-offs to maximize a score. Chooses actions that minimize a utility score, accuracy versus speed versus diversity. Typically, the more speed means the less accuracy. The more data, less privacy. These are trade-offs. Here's an example. A recommender system balancing a click-through diversity, long-term user satisfaction, for example. It's a utility score, not merely hitting a single goal. Self-driving cars, they trade safety, comfort, and time. Perhaps to get there at a quicker time, you may have to lessen the degree of comfort, but you set thresholds. The cloud autoscaler balances latency targets with compute costs. AI engineers should identify the score that they're optimizing and how costs and constraints change decisions. Onward. Self-improving autopilot. It improves the model's rules or policies from data and feedback. It can wrap any prior type that we have. Examples, Spam filter updates from user flags, thumbs up and the thumbs down. Reinforcement learning agents, AlphaGo, learns a better policy from rewards. Remember the AlphaGo, it started its debut with the Go game. It's a Chinese game, and that took place. DeepMinds at the time, before Google had purchased them, uh, embarked upon this grand challenge, the Go game. Lee Sudoku from met a champion Go player. They met up in South Korea. The human won the first game, the machine won the other four. Lee Sudoku resigned. This machine was never trained on how to play the game. It was just given the rules, thumbs up, thumbs down, depending on the moves that it made. Reinforcement learning. Personalized study coach adjusts difficulty from quiz feedback. How fascinating. Uh, this is the notion of personalized learning. Looking forward to personalized healthcare. Close by connecting learning groups, feedback, update, evaluate, and responsible monitoring. Let's put this together in a real-world patterns. Most agentic apps combine memory, that's context, goal-driven tool use, you give it an order, so this is what I want to achieve, a utility step to pick the best option, and a light learning loop from feedback. Examples, travel planner. We have our preferences. Flight, hotel, so there are APIs that are playing here. Budget, there's a comfort score. The machine needs to adapt as we give feedback to the system. What works for us, what are our preferences, and what to avoid. A RAG analyst, retrieve, re-rank, cite your sources, visualize, and learn from the edits. We call RAG retrievable augmented generation. Scheduler, calendars, plus time zone helper. And fairness score, it learns preferences. So it's a great example of, for example, a scheduler that how it can adhere to our own whims, preferences. How about the agentic flow at a glance? There's always a continuous adaptation going on. It's data-driven updates. It updates the model's thresholds with new data and feedback. Perhaps you've set a scheduled retraining, or it could simply be a simply rule adjustment at that point. Refresh knowledge. Docs frequently asks, for example, and reevaluate the prompts regularly. So there's a constant feedback going on in here. Roll back if metrics drop. Guard against drift. Drift is a big concept. Quite a few slides later, we're going to chat about drift. Context handling. We have an entire video set on context. Structured input, then go fetch it. Transform raw input into structured fields, including intent, entity, IDs, and dates. Intents are verbs, entities are nouns. Pull relevant info from retrieval embeddings, not understanding, just matching meanings. Combined with session plus saved preferences to keep only what's needed. Notion of context handling. Task automation at a scale, also known as orchestration. Orchestration is a big undertaking by AI engineers and many software companies. They have orchestrator that brings this whole entire tool sets together. Trigger workflows via queues, timers, webhooks. It runs stateless workers in parallel. So these are not stateful, does not remember, but runs them in parallel. Standardize prompts or templates, add retries, timeouts, and rate limit handling. All about task automation. Track costs and latency per task. set budgets, and alerts. Again, these are automation tasks where an orchestrator brings forth that automation. And then there's the decision layer. There's a score, there's a choose, it keeps a log. Use a simple utility score, benefit, cost, risk, with weights, saliencies that you attach to the hyperparameters. Pick the action with the highest score. Escalate it on low confidence values so the AI engineers can address that. Log inputs, chosen action, and metrics for audit and improvement. So the decision layer is at some point, it's perhaps best addressed when you pass it to the human for certain checks that the feedback loop may have missed. Excellent. Our next slide is about the components of agentic AI. I am looking forward to chatting with you at that time. See you soon.